Okay, now we're looking at, excuse me, we're looking at number 15 now. Find the altitude of an isosceles triangle with base 10 and congruent sides of length 9 and round to the nearest 100th. Okay, so we've got an isosceles triangle with a base length of 10, and the legs, the congruent sides, have a length of 9 units. And we're asked to find the altitude. Remember, the altitude goes from a side perpendicularly to the vertex. All right, let me try one more time. I'm not going to insist that it's perfect, but we've got, okay, so this altitude is perpendicular to the base going to the vertex. And we're looking for the length of that side. So one way that we can approach this is, okay, we need to know that for an isosceles triangle, the altitude is also a perpendicular bisector and also an angle bisector and a median. They're all the special segments of a triangle. So what we've done with this altitude is we've created two right triangles, and since this altitude for an isosceles triangle is also a perpendicular bisector, then from this point to this point is half of the base. So this side here is 5 units long. And so you see here now we can use the Pythagorean theorem to find the length of the altitude. If we call this A for altitude, all right, we have A squared plus 5 squared is equal to 9 squared. Okay, the sum of the squares of you square the legs, add them together, and that's equal to the square of the hypotenuse. So we're solving for A. Well, let's just go ahead and we got A plus 25 A squared plus 25 is equal to 81. We're going to solve for A, so we need to get A by itself. So I'm going to subtract 25 on each side. So A squared is equal to, what, 56? And then A, and we have A squared now, but we want A. So we need to reverse what's being squared here by taking the square root. So A is equal to the square root of 56, which is approximate, let's just, well, first of all, let's simplify that, just some practice in simplifying radicals. So I'm going to break that down into factors where I can possibly get a square root that's a perfect square. And I can break this down to the square root of 4 times the square root of 14. 4 is a perfect square. The square root of 4 is 2, so I have 2 square roots of 14. And so A is approximately, I'm going to do the square root of 56. It's the fastest way to do it. 7 point, and let's round to the nearest hundredth, they said, so it's 7.48. Okay, so this was not a necessary step, but I just wanted to look at simplifying a radical real quick. 7.48 to the nearest hundredth is the length of the altitude. Number 16, find the area of the rectangle. Area of a rectangle is length times width, and we don't have either one here. When we look at this figure, we see that from here to here, that's 8 inches, and it looks as though that would be 8 inches as well. So we could say the length is 16. But how do we know for sure? When we look at the figure, we see that two right triangles are formed, and they're congruent. How do we know they're congruent? Well, if this is a right angle, then this is a right angle as well. And we see that the hypotenuses are congruent, and then this leg is shared by both right triangles. So those legs are congruent to each other. And so by the hypotenuse leg theorem, you could also say that from here to here is 8 inches as well. So we have, let's call that the length of 16. And now we need, we'll call this the width. I have 2 sides out of 3 for a right triangle, so again I can use the Pythagorean theorem to find the length of this leg. And let's just call it W for width. Okay, so what we have here is w squared plus 8 squared is equal to 10 squared. So w squared is going to equal 100 minus 64, which is 36, and w is going to be the square root of 36, which is 6. Okay? 8 squared is 64, 10 squared is 100. To get w by itself, I subtracted 64 from 100. That gave me w squared is 36. So w has to equal the square root of 36, which is 6. So now I have the length and the width. So the area is going to equal 8, the length, times the width, which we said was 6. So the area is 48 square inches, which is answer choice C.